Students, welcome back to the second part of the lecture number 10. So, we have been discussing about ensemble learning. In particular, we have been discussing about adaptive or AdaBoost algorithm, right. And as you know, this is a very classic boosting algorithm for ensemble learning. And I told you there are 4 steps in this algorithm. Let me iterate again these 4 steps. So, first step is what is your data sets are divided into different data points. Okay, that is what the first data sets is about it. So, here in the last picture I shown you different color of balls or circles, red, blue, green, and initially we have no residues, we apply equal weights on these, and the first weak classifier will divide them into different red balls, blue balls, green balls, right. Obviously, initially there will be a lot of errors because you put equal weights. In the second case is the steps 2, we adjust the weights. Why? Because first step we have made some errors, we adjust the error, right. We put higher error weights, that is what is shown in the dark points. You can see here we put higher weights, right, in these points which were basically blue, because these are coming wrong, right. So, it is green, not blue, these green balls or circles are coming wrong. So, we put higher weights on them, correct. And next classifier will be trained, and then it will refine the descent boundary, so that we can have more blue balls. Can you see that, right? The second classifier. And in the third step, we can further adjust, because there will be always some errors, further adjust to do that better classification. The classifier will adjust again using the improved descent boundaries, and that is how finally in step 4 we can ensemble or combine actually these steps 1, 2, 3 to get the strength of each of these weak classifiers to build a strong classifier. But you know, in the AdaBoosting we use a very interesting aspect. Let me go back to the board and explain you. In AdaBoosting we just use a very interesting concepts. Okay, so let me just tell you that. So, as you say, this is, and let us say the training data contains in data, right. How do you write it? Very simple, xi, yi. Xi is your input variables, y is your output variables, right, and I can go 1 to n, small n, right, and yi can be minus 1 or plus 1, the two binaries, either it can be negative or positive, right. So, it basically develops, this model is basically develops on the based on the exponential loss function. You can write down loss of error also, right, error function, loss function. So, loss function is y write small g, these are the learners. We use here exponential loss function. So, obviously, I goes to 1 to n exponential minus yi this is the loss function use. This is basically minimized, remember this. This is error function, this has to be minimized. That is the idea. So, in AdaBoosting, we obviously very important aspects is that we use exponential loss function. Please remember this, okay. And here GI, as we mentioned actually, GIX is basically a learner, base learner. I think you better use the black one. Blue always create a problem. This is a best learner, okay? And so if, I hope you understand that. And basically, so we can always do a little bit of mathematics on this. What you can do on this? Very simple maths, not very difficult one. So in order to minimize the error, we just take derivative with respect to, so better write del. So if you take a derivative of that, what you get? You get minus yi exponential minus yi gixi, right? That's we can write down always minus exponential minus gi x multiplied by p okay plus exponential minus what I am doing. Remember I told you that y in data was xi yi, right? I wrote, and I goes to 1 to n, okay. Yi can have value plus 1 or minus 1. So I am using that. Okay. So that's the idea. Very simple idea. We expand that. So now we can always write down then. We can always write down from this. We can always write down because we are optimizing the learners, right? This will be equal to half log of p gi p okay. So you get a very important equation for the best learner, okay. See, remember gi is actually learners, right? All the g's are actually learners we are using in this lecture. So therefore we can clearly see that the sign of gi is can be depends on sign of these two, right? This is log, so log has to be positive. That's the idea. So you can choose the learners in such a way that gi become minimized, right? That's the idea. That's the main concept behind these mathematical derivations, okay. So we use exponential loss functions, and that's how we can derive this equation. So I will not go more details about that. So this is what actually your AdaBoost algorithm is about. What is gradient boosting algorithm? Well, it also combines multiple weak learners to create a strong predictive model. But what is the difference then? Again, it constructs models in sequential manner, but here each weak learner, remember this, minimize the residual error of the previous one by using the concept called gradient boosting or gradient descent, sorry. I already discussed about gradient descent model to you, and you probably have understood it. If not, please go back to my lecture again. So what we are doing, we are using again series of learners, sequential manner, okay. But each weak learner minimizes here the error or residual error simply by using gradient descent technique, okay. And this reduces error simply directly by optimizing this loss function. Loss function can be mean square error, right, or maybe enthalpy, cross enthalpy. So remember, in each iteration this algorithm computes the gradient of the loss function with respect to the predictions, and this is followed by training a new weak model to minimize this gradient. So in case of ADA boosting, we are basically trying to, each model, subsequent model, are trying to correct the error committed by the preceding learner, base learner, right, preceding base weak learner. Here we are not doing that. Here we are computing the gradient of the loss function. Loss function can be simply mean square error or any other thing, cross entropy or MAE, okay, many other loss function exist. And then this is followed by training a new weak model to minimize this gradient. So prediction of the new models are then added to all the model predictions, and the process is always repeated or iterative until the stopping criterion is met. Remember this difference, okay. So you are using a gradient descent technique, that's why it's called a gradient boosting technique, okay. So let me just tell you what is the gradient descent model algorithm. I already discussed in the last lecture, lecture number 9 probably some part. This is used to find the best solution to a problem by making small adjustment in the right directions. So it is, what is this? Let me explain you again. It is like to find the lowest point in the hilly area by walking down the slope step by step until you reach the bottom, okay. So you are sitting at the top of the hill and you are observing the path, best pathway to reach the bottom of the hill, correct. You may have many pathways, but you will select the path which is the highest slope downwards, right, so that you can reach very fast, correct. Obviously, you must not try, you may fall and may have accident, but in a mathematical technique, that is what is done. Mathematically, we are trying to find the lowest point in the error function, and we like to go down that lowest point as fast as possible. So that computational power is also reduced, right. So as you know, gradient is simply nothing but the slope of the curve, right. Basically, the slope can vary depending on the directions in which it is measured in the context of curves basically, and therefore gradient provides important about the rate of change of the functions output with respect to the change in the variable. That is what, because we know straight line is y is equal to mx plus c, right. So here m is the slope. So it is providing information about the rate of change of the y when x is changed. When x is changed, how that. So basically it provides you information about dy dx, right. That is what is called rate of change of y with respect to change in the inputs. So how does it work? Again, stepwise business. Step 1, you can start at the top. Basically, you can choose any random guess of the model parameters. That is what you do. The steps 2, you have to fill the slope. Which of the slope is going down and which is the best way of reaching the bottom of the hill. So look around, find out the directions. The ground is sloping down. Basically, what do you do? Calculate gradient at each directions, and then after calculating gradients, you will find which is the steepest gradient to go to the downhill. So once you know the steepest gradient, you move in the direction in which this gradient is steep. So bigger the slope, bigger the step you can take, right. So at step 4, you repeat that. So this model actually learned and minimized the error. Again, very important model. So gradient descent moves towards the bottom or minimum of the loss functions basically by doing this, by taking a fastest gradient, and it is very quick, it is very easily done. So basically you have to minimize the cost functions, and it is done by iterative method obviously, and this is what is shown here. Let us say you have a initial weight, this is your what is your derivative of the cost function, first derivative, right, because you want to minimize the error or cost. So you have to take derivative of that That is what we always do, and this is your minimum point. So, now we can start from here, put any initial guess or error, wait and take incremental steps, so that you can reach here, right. You can also start from here, right, and reach step by step. Both the ways you can reach that, and each point you are calculating the gradient, right, and you are taking the best highest gradient by which you can go down. Well, I do not want to discuss about cost function again, so we have discussed about this, but remember, you have to do that, you must have two important criteria to be met. One is the gradient descent requires the cost function to be differentiable. If it is not differentiable, it cannot allow you to compute the gradients, right. Secondly, it also have a convex character. The cost function should ideally be convex to ensure the gradient descent readily find the global minimum, right. The picture I showed you just now, this has to be convex, so that it can find the gradient descent at the bottom of this curve, right. That is what is the idea is. So, descent can reliably find the global minimum very easily. Convex person is, what is convex? The second derivative is non-negative across its domains, right. That is what is a convex function is. So, in a gradient boosting, what you do? So, that is what the gradient descent. We always initialize the model, okay. Basically, you can start with a very simple model like regression. Regression is the simplest weak model, remember that. So, then you calculate the residuals, errors, right. Compute the difference between the model predictions and the actual values. That is what is called residual errors. Remember, this error, loss, error, residual, in machine learning, they are used very same way. Loss functions same as error function, residuals means difference between model prediction and the actual value. So, once you know that, you know the difference between that, then you can train a new decision tree or any other weak learner, basically any other weak learner to predict the residuals. Well, you probably I am not taught you about decision tree. We will get back to decision tree in the next couple of lectures. So, maybe more. So, decision tree is something in which we can actually divide or partition the data in different parts, basically classify, partition it in different parts by using just like a tree structure. In a tree, you have tree trunk followed by leaves and connected with junction points, right. So, this we can use multiple trees to make the decisions possible. That is what it is. So, basically idea is to have these residuals and train this new decision tree to predict the residuals. So, add this in the fourth step, what you do, you can update the model, add the new decision tree prediction to the ensemble, and it can be weighted by some learning rate. Okay, I discussed about learning rate, you can go back and understand that. So, in the fifth step, you can repeat this step 2 to 4 again and again. Basically, you can add more trees or less trees and update a model depending on the stopping function criteria is met or not. Okay, that is the idea in gradient descent technique, and that is why gradient boosting technique is so powerful and it is widely used in the literature. The two important steps you have to understand, one is called sequential learning process. The ensemble consists of multiple trees, like I told you, decision trees, and each required to be trained to correct the errors of the previous ones. That is the key thing for any boosting algorithm, right, is it not? So, T1 is trained on the original data XX or X actually and Y, and it makes predictions which are then used to compute the errors further. The second iteration, which is called residual calculations, first we take the difference between error and actual value, that is called residuals, and T2 is trained using this feature matrix XX and error from the T1, not on Y. So, remember X and Y, right, we are training using original data. Here we are not doing that, we are using Xi and error. Okay. So, if I take error in the T1, okay, that is what. So, we can actually train the second tree using not new Xi, Yi, but this X and the error as the levels. This means T2 is trained to predict basically errors of the T1, because we are using error as a level. So, this process will continue or this process will go back and forth, that is what is called 2 and 4 is goes back and forth. That is what is called. This step 2 and 4 are repetitive or iterative. Okay. So, this is the main difference between ADA boosting and gradient boosting. In gradient boosting, basically first we calculate the error, and then the next tree is basically trained to predict errors for the other tree or previous tree. Remember this. This is the main difference between the ADA boosting and the gradient boosting. Okay. This is shown here. I am showing you n trees T1, T2, T3, Tn, correct. And you can clearly see this is what is your data, and T1 calculate error also. This is what is your predicted data, this is your original data, error, correct. So, finally, you get new training set, this is what is used, correct. First, let us take the training data, put on a tree, make a predictions. For the prediction, you calculate the error R1. The next tree, we are basically using X and R1 as a data. Put in the training tree, calculate again error R2. Again, this R2 is fed in the next tree, correct, and goes on. So, these errors or residuals are basically used as a level for each of these iterations to minimize that, and we do it for n steps. Very powerful technique, all of you, those of you who use it, you know, very powerful technique, gradient boostings, and it takes care of many important aspects. Now, in the last part, I just introduce what is XZ boosting. I may not discuss because it requires me to talk about decision trees, and we can come back to it. XZ boost uses a decision tree as a best learner and combines them sequentially to improve the model performance. Each tree is trained to correct the errors based on the previous tree. It has a built-in parallel processing technique to train the models on large data sets. Okay. So, XGBoost is very good for large data sets, remember this. And finally, basically speaking, it is a model which is more widely used than adaptive learning or whatever, or the residual learning technique also, but it is not so easy to use in normal way. Okay, not so easy to use. So, ideally speaking, both XGBoost and the gradient boosting techniques can be used parallelly, or you can use either of these techniques, but XGBoost has much higher capability. You can use many number of trees and decision trees as base learners and combine them sequentially to improve the model performance. So, we will stop here, we will come back in the next lecture on something new. Let me go back and tell you that what is that. Okay. In the next lecture, we will talk about these aspects, ML models with applications. So, we may start with some linear models just to discuss initial aspects, and directly go into SVM, support vector machines, decision tree. Okay. Bayesian we already discussed, we will not discuss here. Then we will discuss a neural network and clustering, visualization, transformations, other aspects. That will take about 5-6 lectures or more than that even. So, this is the main idea. So, we are going to start the third portion of the lecture and discuss it in the next lecture. Thank you.